Now let's look at some concrete examples of how to evaluate the inverse tangent or inverse trigonometric functions. I think using the unit circle is a great resource. I'm also going to show you how to evaluate these using triangles, but if you can get a picture of the unit circle in your head or be able to draw a rough sketch of it, it's going to help you a lot. If we want to find the inverse sine of -1, remember from the unit circle that x values are cosines and y values are sines. So we want to find a y value, the angle where the y value is -1. Notice that occurs right here. However, from our videos on the domain of the inverse trig functions, we know that this 3 pi over 2 doesn't fall into the correct category. However, we can evaluate this as negative pi over 2, and it hits the same point. So the inverse sine of -1 is negative pi over 2. If we look now at the cosine of square root of 2 over 2, here we want to find the angle whose x value is square root of 2 over 2. Simply by referring to our unit circle here, we have square root of 2 over 2. If you want to do this in terms of a triangle, we know this is going to be pi over 4, but remember cosine is adjacent over hypotenuse. And so we can use the Pythagorean theorem to get that square root of 2 squared plus the unknown side squared is going to equal 2 squared, which results in 2 plus x squared equals 4, leaving us with x squared equals 2. So these sides are equal, leaving us with a 1 square root of 2 triangle, which tells us it is pi over 4. To evaluate the inverse secant, remember that we can also evaluate this as we want the cosine of theta to equal 3 over 2 square roots of 3. If we rationalize that denominator, I'm going to multiply top and bottom by square root of 3 over 3, which leaves me with 3 square roots of 3 over 6, or square root of 3 over 2. When I go to my unit circle, square root of 3 over 2 occurs here and here. However, pi over 6 is what falls into the correct domain range area for the functions that we're looking at. So here we're going to end up with pi over 6. I'm going to leave these two for you to try and evaluate. Again, here you're going to try and find where a y value is -1/2. Make sure it falls into the correct quadrant. And here, when you evaluate this one, you're going to end up with the inverse cotangent also comes out to negative pi over 6. And again, if you have trouble with those, let me know. The last thing I want to show you briefly is the idea of compositions of these functions. So for example, if I have the tangent of the inverse of the sine of negative square root of 2 over 2, I want to find what this angle is first and then figure out the tangent. Again, I need a y value of negative square root of 2 over 2, which is right here. But to get it into the correct domain range when we're looking at these inverse functions, that is going to have to become negative pi over 4. So we have the tangent of negative pi over 4, which, remember, tangent can be found by calculating sine over cosine. So if we look at our unit circle, we're going to have negative square root of 2 over 2 divided by square root of 2 over 2, which results in -1. The last thing I want to show you, if you need to evaluate these functions on the calculator, there is an inverse function for trig functions on the calculator for Desmos. As soon as my screen loads here. So if you go under function, you see the inverse functions are there as well. Just make sure you are in the proper mode, either radian or degree, depending on what is asked for.